In October of 1900, a Greek sponge diver broke the surface of the Aegean Sea, trembling. He reported finding a graveyard of corpses resting in the silt on the ocean floor. The corpses were actually Roman marble and bronze statues scattered from a shipwreck. But the most valuable item hauled onto the deck was a dense, shoebox-sized lump of corroded wood and bronze. For half a century, it sat in a museum, assumed to be a basic astrolabe. Then, X-ray imaging revealed an artifact that defied history: dozens of precision-cut bronze gears. The Antikythera mechanism was an analog computer built over 2 millennia ago. Turning a hand crank tracked planetary orbits and predicted solar and lunar eclipses using a complex pin and slot system. We navigate the world with a comforting assumption. This chart shows the popular view of human history: a steady, unbroken line of constant technological progress. The bronze gears challenge that model entirely. When this machine sank into the Mediterranean, humanity would not invent an instrument of this complexity for another 14 centuries. These artifacts demonstrate that ancient societies possessed engineering capabilities modern scientists are still working to reverse engineer. They are the physical remnants of a lost world. In the 7th century, approaching the Byzantine coastline by sea meant sailing into a uniquely terrifying defensive line. Byzantine ships wielded bronze siphons that sprayed a liquid stream of fire directly onto enemy hulls. The flames miraculously continued to burn right on top of the ocean waves. Enemy sailors who threw water on the flames found that it only caused the inferno to burn hotter. This petroleum-based mixture gave the Byzantine Navy absolute control of their waters. The formula was classified as the ultimate state secret. It was guarded so fiercely by the military elite that the full chemical recipe was never written down. When the empire eventually collapsed, its most effective defense mechanism died alongside it. The exact recipe for Greek fire evaporated into history, erased by the isolation meant to protect it. Sometimes artisans mastered advanced physics entirely by accident. This is the Lycurgus cup, a 4th century Roman glass vessel that appears milky green in normal daylight. But when illuminated from the inside, the glass turns a brilliant, deep red. Modern electron microscopes reveal the Romans achieved this dichroism by crushing gold and silver into nanoparticles, smaller than a wavelength of visible light. 1,000 years later in the Middle East, blacksmiths forged weapons with a legendary reputation. The blades of Damascus steel are identified by the watery, rippling pattern locked into the metal. Crusaders reported these swords could slice through a piece of silk falling through the air, yet bend 90 degrees without snapping. We now know the forging process inadvertently created microscopic carbon nanotubes and cementite nanowires inside the steel. But this metallurgy relied on specific trace elements, particularly vanadium, mined in India. By the 18th century, those regional mines were completely exhausted. The raw materials disappeared and the specific forging technique followed. An entire tradition of ancient nanotechnology vanished because the earth ran out of the necessary ingredients. Imagine standing in a central Iranian courtyard in 400 BCE. The summer air is over 100 degrees. Yet inside this massive cone-shaped mud brick tower, you can retrieve a massive block of solid ice. This diagram illustrates the mechanics of the Persian Yakchal. By flooding shallow trenches at night, heat radiated away from the water and directly into the incredibly clear, dry outer space, freezing the water even when the ambient air was above freezing. The Persians built a lucrative ice trade on this principle, but the global mass production of electric refrigerators broke the chain of master builders, leaving zero-emission desert cooling towers to crumble into obscurity. We often replace ancient methods with modern equivalents that are actually less durable. Steel-reinforced concrete structures routinely crack and decay after just a few decades of exposure to saltwater and weather. Compare that to Roman harbors enduring ocean waves for 2,000 years, or the Pantheon in Rome, which still boasts the largest unreinforced concrete dome on Earth. As this animation shows, the Romans utilized hot mixing, adding dry quicklime into the concrete. When water intrudes through a crack, it hits the brittle lime clasts and immediately sprouts new crystals, permanently bridging the gap. The Romans engineered smart, self-healing infrastructure. We abandoned it for faster, cheaper methods, choosing the convenience of the present over the permanence of the past. These scattered discoveries point to a larger reality about human civilization. Society loses its highest achievements not because the engineering is flawed, but because the world it exists in is incredibly fragile. Knowledge does not automatically survive the passage of time. A sudden plague, a shifting trade route, or a master dying before an apprentice is ready can permanently sever a line of human intellect. The astronomical mastery to build the Antikythera mechanism was buried under the Mediterranean, sitting in total darkness as Europe plunged into the Middle Ages. The architects who froze desert water and calculated celestial orbits did not view themselves as ancient history. They believed they were building the future. Everything a civilization knows and builds relies on the active transfer of information. The moment we stop teaching, the future forgets us.